All right, welcome back to class. Today we'll conclude what we started, dimension analysis. And here we have two questions that will seal up what we've started previous class. Dimension analysis generally have three phases. One, to calculate dimension analysis of the quantity. Two, to determine the value of x, y, z of a dimension analysis of a quantity rather. And three, to check if to determine if an equation is dimensionally correct. So let's start with this first question without wasting much of our time. The first says that find dimension analysis of Young modulus, hence determine the value of x, y, z. Now, Young modulus is a quantity, okay? Young modulus is a quantity which the formula is stress over strain. Now, if you are to determine the value of x, y, z of any quantity under dimension analysis, the first thing for you to do is to first determine dimension analysis first. You need to get the value of MLT. You need to make it in such a way that you have MLT. From there, you can then proceed to this. I'll get to that. So first thing for us to do is to first look at the dimension analysis of Young modulus. And what's the formula? The first thing I told you yesterday is that for every quantity, you must recall the formula. The formula is stress over strain. And I told you yesterday that the next thing is to look at the quantity again and see if those formula have a formula or has a formula. Now, stress. Does stress has a formula? Yes. And the formula of stress is force over area. Okay. Now, does force has a formula? Yes. What is the formula of force? The formula of force is mass times acceleration. So I just replace this guy with this because of time. I know you understand what I'm doing now from the previous class over area. Then does area also have a formula? Yes. Does area have a formula? Yes. What's the formula for area? Length times breadth. Okay. Now we'll go back to the formula. Does mass has a formula? No. Has a formula? Yes. The formula is what? Mass times what? Change in the velocity over what? Time. That's the formula for acceleration. So I'm replacing acceleration with this guy over L times what? D. Because this is not a formula, this also does not have a formula. So what's the next thing? Velocity. Does velocity have a formula? Yes. What is the formula? Displacement over what? Over time. So I have mass times, so I replace that with what? Displacement over time, which is the formula for this one, then over time, then over length times breadth. I'll go again. Does that the formula? No. This guy no. This guy no. This guy no. This guy no. Then I apply what? MLT. Mind you, I'm still solving for stress. I'm solving for stress. So what do I do? Mass is measured in what? In terms of M times, this guy is L over T. From yesterday, we should know that over T over L times B. I mean, your breadth also measured in what? In length. So this will give us M L T minus 2. I know you know what I've done here. Minus 2 because you have two T's here. We'll pick one. You know, from here, we have LT minus 1, right, over T. Then you pick one T. So LT minus 1 minus 1. Because you're dividing minus from the law of initial I told us yesterday. So then we have LT minus 2. That's how we have that over L squared. Then from here, I have M. You pick one of the L. 1 minus 2. Because this one is the power of 1. Division minus then 2. T minus 2. So then I have M. L minus 1, T minus 2, because 1 minus 2 is what? Minus 1. So I have M minus 1 minus 2. Now we have done for stress. Now for strain. So strain is equals to, the formula for strain is extension over length. The extension has a formula? No. Does length has a formula? No. So that means extension is measured in, if you want to measure extension, is length. If you apply MLT, So your strain is equals to L over L. And that will give us L raised to the power 1 minus 1. And that will give us L raised to the power 0. And in this, anything L raised to the power 0 is what? Is 1. So at the end of the day, stress over strain, our Young modulus is equals to the dimensional of stress is M L minus 1 T minus 2. That of a strain is what? 1. So that means Young modulus is what? M L minus 1 T minus 2. That's the first step. Don't forget, to have to find X, Y, and Z, not dimensionality. So don't dimensionality. So how do you get that? Basically, if you compare, M is always raised to the power X, N is raised to the power Y, and T is raised to the power Z. So you compare these two together. So what is X? X is equals to this M raised to the power. So M raised to the power what? So X equals to what? 1, because this is the power of 1. Y, what is Y raised to the power? If you compare L and L, Y and this is equals to what? Minus 1. Then Z equals to what? Z equals to what? Minus 2. That's the final answer. So if you're looking at that question, that's what you should do. Okay. Sometimes they might define X for you, Y for you, and Z for you with a particular number. What do? After comparing, you multiply. Say, for example, X defined for us for 1, Y is 0, and Z is this. So while you're comparing, you just need to multiply. Then you get that. Then the second one, we have to check if that equation is dimensionally correct. So what do? On Y, I'm going to check if it's dimensionally correct. So the rule is that your left-hand side must be equal to right-hand side. So if it's equal to this, it's dimensionally correct. If it's not equal to that, it's not dimensionally correct. So what that means that you are going to solve for this, solve for this, solve for this. If they are all the same, then they are dimensionally correct. Because of time, V is velocity. And another dimensional velocity is what? L raised to power, LT minus 1. Because velocity is displacement over time. Okay? Velocity displacement over time. So this is just L over T. And this is LT minus 1. So this guy is just LT minus 1 raised to power 2, because of this square, equals to, use initial velocity. You have the same formula. So it is still LT minus 1 raised to power 2 plus acceleration is LT minus 2. LT minus 2. So we have LT minus 2 times distance is L. L. Okay. Distance is what? Is L. So now these two affect the whole of this law of indices. Okay. So this one is same as saying L squared T 2 times minus 1 minus 2 equals to this also L squared T times minus 1 T minus 2 plus, now this is L and L. We pick one, right? It has a power of 1 here, power of 1 here. 1 plus 1, 2. T minus 2. You can see that this is equal to this and equals to this. Therefore, this equation is what? Dimensionally correct. If it is not, if this one has L2 squared T minus 2, this has L3 T minus 2, and this has L2 T minus 3. T minus T minus 2. It is not going to be dimensionally correct because they are not the same. So since left-hand side is equals to right-hand side, then you can say this equation is dimensionally correct. You can try questions out on this so that you can be sure that you have a grip and the knowledge of what we have done. So this is the end of dimensional analysis. See you in the next class. Ciao.